Okay, good morning Year 5. It's Tuesday. Hopefully you had fun with this morning's challenge. And we're going to dive right in, so hopefully this video is a little bit shorter than yesterday's. And we are going to go through today, so Tuesday's mathematical talk questions. Our first question is what equivalent fractions can we find by folding the paper, and how can we record these? So it's important that you have a piece of paper. If you're going to do it with multiple pieces of paper, they all need to be the same size so you can see that they equal each other. So before we do any of that, let's just check that we understand what equivalent fractions means. So an equivalent fraction is two fractions. They might look different, but they actually are the same amount. Okay, so it'll be a bit easier to show you if I show you with a piece of paper. Okay, so piece of paper. Fold it in half. Okay, then on each half of this, we can write 1/2. Okay, the whole thing together, so all of this space would be 2/2. Okay, that's how many parts we've got. We've got two parts. That's one part of the two, and that's another part of the two. Okay, what we're going to do now is we're going to find an equivalent fraction to that by doing some folding, the same size piece of paper. So we fold it in half once, then we can fold it in half again. Okay, fold that out again. So now you can see the denominator is going to be how many pieces we have. So we have 4 pieces. So on the bottom of each of these, we're going to put 4. Each is 1. The whole thing all together is going to be 4/4. Okay, so we can see 2/4 is the same as 1/2. They fit together perfectly. They are the same amount of space. Okay, for the whole pieces of paper, 2 2s, 1 whole, is the same as 4 4s. Okay, I'll show you one more. You can carry on doing this until the paper's got loads and loads of folds in it. Okay, so folded once, folded twice, folded, trying to do it 3 times. Okay, fold it out again. Our denominator is going to be how many little folds we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 8, 8, 8, 8, 8, 8, 8, 8. Each one is 1. Okay, and the whole thing is 8/8. Okay, now we're going to see how many. So first of all, we already worked out half is equal to 2/4. Remember, half and 2/4 fit together. That line is in the same place. Okay, now with those lined up, let's see how many 8s fit on there. Okay, 1, 2, 3, 4. 4 8s. Okay, all of those 1/2, 2/4, and 4 8s are equivalent fractions. They cover the same amount of space, even though they might look a little bit differently. You can also check these by simplifying them down. So you can simplify them all down to this number. Okay, so remember, when we're doing any kind of fraction work, we need to do the same to the bottom as we do to the top. So with this one, to get the 2 to become 1, we need to divide it by 2. And to get the 4 to become 2, we need to divide it by 2. So that's going to be 1/2. This one here, to get the 4 to become 1, divide by 4. To get the 8 to become 2, we divide by 4. So again, 1/2. You can see there, those look different, but they can be simplified to equal that same number. Okay, so it's a nice in-depth explanation for that first one. As I said, you can carry on going, but my paper's a little bit small, so I'm not going to keep on going. But you can see that all of those fit together perfectly. It's quite nice to do it practically sometimes, because then it might make a little bit more sense to you. Okay, our next question. What is the same and what is different about the numerators and the denominators in equivalent fractions? Okay, so here, let me just highlight them. We've got two equivalent fractions. We've already looked at those up here actually. Okay, numerators and denominators. Hopefully, you guys know what those are. The numerators is the top numbers. Denominators, I always remember denominators, D for down, is the bottom number. Okay, so what is the same about the numerators in these equivalent fractions? They're not the same number, are they? But we can see that they both are in the same times table. Okay, 1 times 2 equals 2. Okay, what is the same about denominators? Again, they're not the same numbers, but they are in the same times table. 2 times 2 equals 4. Okay, right. So nice simple one. They're not the same numbers, but they are in the same times table. And on to question 3. We'll leave that one because I think that's simple enough anyway. How does multiplication and division help us find equivalent fractions? Where can we see this in our model? Okay, so I've already shown you a little bit by here. Here we've used division to show that they're the same. Okay, here I'll show you how we can show that they are equivalent with division and multiplication. Okay, so let's highlight our original. Those are our original numbers. Okay, so I've already told you those are equivalent fractions. Okay, so what we are going to do first is we're going to make this one equal this. Okay, this one's the smaller number, so what we're going to have to do is divide this fraction. Okay, so what we need to work out is how we get from 4 to 12. To get from 4 to 12, we need to do our times tables. We do 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12. Okay, so that's 3. But because we're going down, we're not going to do times, we're going to do divide. Divide by 3. Okay, now let's just check this works with this one as well. So 10 times 1 is 10, 10 times 2 is 20, and 10 times 3 is 30. And we're making it smaller, so again we're going to divide. So divide by 3 works for both of them, so that's great. So what we are going to do, 12 divided by 3 is 4. 30 divided by 3 is 10. Okay, you can see that there they equal each other. Okay, so that is our division to show that they are equivalent fractions. Okay, now we're going to work on this one over here to show that it's equivalent to this with timesing. So we're going to go the opposite way to try and make it into that number. Okay, so as we've already worked out, we are working at the number 3 here, but as we're trying to make it a bigger number, we need to times it by 3. So 4 times 3 is 1 times 4 is 4, 2 times 4 is 8, and 3 times 4 is 12. So 12, and here, 10 times 1 is 10, 10 times 2 is 20, and 10 times 3 is 30. Okay, so there we can see that this number can be transformed into that when we do the same to the bottom as we do to the top. So that is how we can use division and multiplication to check that fractions are equivalent. Okay, I think that was a bit quicker than yesterday's video. Fingers crossed. Yeah, okay. Okay, thank you everyone. I hope that made sense, and I'll talk to you again tomorrow.